In the realm of software development, quality reigns supreme. A buggy application can erode user trust, lead to costly fixes, and tarnish a company's reputation. Among these, white box testing stands out as a powerful method for examining the internal structure and logic of an application. Unlike black box testing, which focuses solely on inputs and outputs, white box testing delves into the very code that drives the software. It's akin to a skilled mechanic meticulously inspecting the engine of a car, scrutinizing each component to guarantee optimal performance. By understanding the inner workings of the software, testers can identify potential flaws, optimize code efficiency, and ultimately deliver a higher quality product. As software grows in complexity, so too does the potential for hidden defects. By employing white box techniques early and often in the development cycle, teams can identify and address issues before they snowball into major problems. This proactive approach not only saves time and resources, but also fosters greater confidence in the software's reliability. By understanding how the software is built, testers can design more comprehensive tests, ensuring that all critical paths are thoroughly examined and potential vulnerabilities are exposed. White box testing encompasses a variety of techniques, each designed to scrutinize different aspects of the source code. By employing a combination of these methods, testers can gain a comprehensive understanding of the software's behavior and identify potential defects lurking beneath the surface. One fundamental technique is statement coverage, which aims to execute every single line of code at least once. This approach ensures that all statements are syntactically correct and function as intended. However, statement coverage alone may not uncover all logic errors. Branch coverage takes a step further, aiming to test both the true and false outcomes of every conditional statement, if-else, switch case. Path coverage delves deeper into the software's execution flow. It aims to test all possible paths through a given section of code. While achieving 100% path coverage is often impractical, it's crucial to identify and test the most critical paths to ensure robust functionality. Condition coverage focuses on testing all possible combinations of conditions within a decision point. Loop coverage focuses specifically on testing loops, ensuring that they iterate the correct number of times and handle edge cases properly. By thoroughly testing loop behavior, developers can prevent infinite loops, off-by-one errors, and other common loop-related issues. Statement coverage, as the name suggests, focuses on testing every single statement within the source code. Achieving 100% statement coverage means that every line of code has been executed at least once during the testing process. This approach helps ensure that there are no syntactical errors in the code and that each statement behaves as expected in isolation. While achieving 100% statement coverage might seem ideal, it's essential to understand its limitations. Consider a scenario where a critical piece of code is never executed because of a logical error in a preceding conditional statement. In such cases, even with 100% statement coverage, a critical bug might remain undetected. Despite its limitations, statement coverage serves as a fundamental metric in white box testing. It acts as a baseline, ensuring that at the very least, every line of code has been executed. This helps identify basic syntax errors, typos, and other issues that might prevent the code from compiling or running successfully. Statement coverage, therefore, acts as a stepping stone towards achieving higher levels of code quality and reliability. Branch coverage delves deeper into the code's logic, focusing on conditional statements that dictate the flow of execution. These statements, often in the form of if-else or switch case blocks, represent decision points within the code. Branch coverage aims to test both the true and false outcomes of each conditional statement, ensuring that all branches of the code are exercised. Imagine a scenario where an online store offers a discount based on the customer's cart value. The code might include an if statement that checks if the cart value exceeds a certain threshold. Branch coverage helps ensure that the code behaves as expected, regardless of the conditions encountered during execution. Branch coverage is particularly crucial in situations where the software's behavior heavily relies on complex decision-making processes. Path coverage takes a more exhaustive approach to testing, aiming to execute all possible paths through a given section of code. A path represents a unique sequence of statements executed from the start to the end of a code block. Achieving 100% path coverage implies testing every possible permutation of execution flow, considering all conditional statements and loops. Consider a code block with two consecutive if statements. Path coverage would involve testing not only the individual true and false outcomes of each if statement, but also all possible combinations of outcomes. The advantage of path coverage lies in its thoroughness. By testing all possible paths, it aims to uncover hidden defects that might not surface through statement or branch coverage alone. In complex software, prioritizing critical paths based on their likelihood of execution and potential impact becomes crucial. Condition coverage dives deeper into the decision-making process within the code, focusing on the individual conditions within conditional statements. A conditional statement, like an if statement, often involves multiple conditions combined using logical operators like and, or. Condition coverage aims to test all possible combinations of truth values for these individual conditions. For instance, consider an if statement with two conditions, age 18, and location =US. Condition coverage ensures that the code behaves correctly regardless of the truth values of the individual conditions. The significance of condition coverage lies in its ability to uncover defects related to complex Boolean expressions. By testing all possible combinations of condition truth values, condition coverage provides a more granular approach to testing decision-making logic. Loop coverage focuses specifically on testing loops, which are fundamental constructs in programming used to execute a block of code repeatedly. Loops can be categorized into different types, such as for loops, while loops, and do-while loops, each with its own syntax and termination condition. Loop coverage aims to ensure that loops iterate the correct number of times, handle edge cases properly, and terminate as expected. For instance, consider a for loop that iterates over a list of items. Loop coverage helps uncover defects specific to repetitive code execution. By thoroughly testing loop behavior, developers can prevent infinite loops, off-by-one errors, and other common loop-related issues. White box testing, with its in-depth analysis of the software's internal structure, offers a plethora of benefits. It plays a pivotal role in enhancing the quality, reliability, and maintainability of software applications. By adopting white box testing practices, development teams can reap the rewards of early defect detection, improved code quality, and increased confidence in the software's robustness. One of the most significant advantages of white box testing is its ability to identify defects early in the development cycle. By scrutinizing the source code directly, testers can pinpoint vulnerabilities and logic flaws that might not be apparent through black box testing alone. Detecting these defects early allows for quicker and less costly fixes. Furthermore, white box testing facilitates code optimization. By understanding how the code functions at a granular level, developers can identify bottlenecks, redundant code segments, and areas for improvement in terms of performance and efficiency. This optimization not only enhances the software's speed and responsiveness, but also reduces resource consumption. White box testing, while often performed manually by developers as they write and review code, benefits greatly from the use of specialized tools. These tools automate various aspects of the testing process, from generating test cases to analyzing code coverage and reporting results. Leveraging these tools empowers quality assurance teams to conduct more thorough and efficient white box testing, ultimately leading to higher quality software. One essential category of tools focuses on code coverage analysis. These tools instrument the source code, tracking which lines or branches are executed during test runs. They provide detailed reports highlighting the percentage of code covered by the tests, allowing developers to identify untested areas and create additional test cases to address them. Popular code coverage tools include Jacoco for Java, Istanbul for JavaScript, and Coverage.py for Python. Another crucial set of tools assists in generating test cases. These tools analyze the source code and automatically create test inputs designed to exercise different paths and conditions. This automation saves significant time and effort compared to manually crafting test cases. Examples of test case generation tools include EvoSuite for Java, PEX for .NET, and Pythoscope for Python. White box testing, with its emphasis on transparency and code-level analysis, stands as a cornerstone of robust software development. By scrutinizing the internal workings of an application, it unveils hidden vulnerabilities, facilitates code optimization, and fosters a culture of quality assurance. Embracing white box testing practices empowers development teams to deliver software that is not only functionally sound, but also reliable, maintainable, and resilient in the face of evolving demands. White box testing provides the means to ensure that the applications we rely on are built on a solid foundation of well-tested and robust code. By embracing the principles of white box testing, developers can instill confidence in their creations, knowing that they have taken the necessary steps to deliver software that meets the highest standards of quality and reliability.